The Pacific coast of Canada, stretching for over 7,000 kilometers along the shoreline of British Columbia. These waters teem with life. But less than a century ago, little was known about these creatures and the silent world they inhabit. That would change because of this man, Reverend George Taylor, humanitarian, naturalist, and amateur marine biologist. His urgent plea for the study and conservation of the marine animals and plants that inhabit these waters would result in this: the Pacific Biological Station in Nanaimo, one of the most eminent marine scientific centers in the world. When George Taylor arrived in frontier Nanaimo in 1893, it was not to build a biological station, but to minister to the coal miners and their families. Taylor was a tireless worker who quickly won the respect of the miners when he showed he was willing to go below to comfort injured and dying men, regardless of danger. Although he worked long hours in his parish, he found a little time to come here, to these beaches and coves which stood in serene contrast to the belching black mine stacks nearby. George Taylor was an avid naturalist and collector, and these shores and tide pools held animals and plants never before recorded. Although he wasn't a trained zoologist, his meticulous notes and observations came to the attention of the scientific community in Canada and abroad. In 1894, his work won him membership in the prestigious Royal Society of Canada, but his triumph was short-lived. The following year, Taylor was overwhelmed by personal tragedy. His wife Elizabeth died in childbirth, leaving him an infant and two small children to care for. Grief-stricken and exhausted, Taylor felt he couldn't cope and resigned his parish and made plans to return to England. But the miners wouldn't hear of it. Sam Robbins, manager of the Vancouver Coal Company, offered the Reverend 100 acres of land on nearby Gabriola Island for $1, if only he would stay. This is the 100 acres Taylor bought from Sam Robbins. Over there is Taylor Bay. It was during the next 4 years of investigations here that Taylor became increasingly alarmed at what he saw happening in Canada's Pacific coast waters. The delicate marine ecosystem was under attack by the greatest predator of all. A whaling industry unchecked. It could only be a matter of time. In the rivers, whole salmon runs were being destroyed. When this log dam blocked the upper reaches of the Adams River in 1903, it completely destroyed a run that numbered in the millions. The run never returned. In the same year, the Fraser River was so overfished that millions of unsold salmon were dumped at its mouth. And Vancouver beaches were so polluted, swimming was forbidden all summer. Up and down the coast, log booming was fouling whole river estuaries. And still the fishing and canning operations from the Fraser to the Skeena expanded, virtually unregulated. Taylor sent appeal after appeal for action to the Dominion government. They responded by appointing him to the British Columbia Fisheries Commission in 1905. The commission agreed with Taylor that the fishing industry should be regulated on a scientific basis. But how? Taylor knew the answer. In 1907, he traveled to Ottawa and presented a paper to the Royal Society entitled A Plea for a Biological Station on the Pacific Coast. The Dominion government responded later that year and voted $7,000 for the establishment of a Pacific Biological Station. It would be at Departure Bay near Nanaimo, on the site of this old Indian fishing camp. Taylor was appointed curator, and he and his son began building the station with their own hands. The two-story building contained a spacious laboratory and a photographic darkroom. Upstairs were 4 bedrooms for visiting scientists. A small flotilla of rowboats was available for observation and collection of specimens. Taylor knew that although he could complete the buildings, he had no funds to pay staff or scientific researchers. So he personally wrote to zoologists and researchers in Canada and abroad, offering them the new scientific facilities on the British Columbia coast to advance their studies. Researchers came from Canada, the US, Britain, Scandinavia. They were a band of aquatic explorers from many nationalities, bound together in a common passion for science and a desire to unlock the secrets of this unexplored world.
This was the starting point. The people who started here, who first came to Nanaimo, had to just identify what was here in the way of different species and to come up with a very simple or starting point kind of idea as to what these different species were doing and how they were interacting in a very simple way. Well, as time goes on, then the information started to grow, and the scientists were able to ask more complicated questions.
What were these plants and animals? How were they constituted? How did they live, reproduce, react with the environment? Only slow, painstaking observation, collection, and cataloging of specimens would yield the answers. The other urgent problem Taylor and the others faced was how to effectively regulate the commercial fishery. This would require a lot more scientific data than they had. So studies began immediately on the reproduction and growth of salmon, halibut, herring, and other stocks being harvested. But it was slow. Nevertheless, they pressed on. Taylor worked such long hours that his fellow researchers became concerned for his health, but he continued to drive himself. Over the next 4 years, a stream of notes, papers, and recommendations poured from his pen. Then suddenly, in 1912, he suffered a massive heart attack and never regained consciousness. He rests here, in Nanaimo, in an unmarked grave, within sight of the sea, and surrounded by the graves of the miners he once comforted. He died intestate. His only assets were his collections and his books. He left them to the station to provide the foundation for a library. He would have been pleased to know it is now considered the finest on Canada's Pacific coast. But George Taylor's real legacy lies in the uncompromising standards he set. He had always encouraged his colleagues to do meticulous, painstaking research, to document it carefully so future scientists could build on their work, to share the fruits of their investigations unstintingly with others so knowledge could abound, to carry out pure research, but always be on the lookout for ways it could be applied practically to the regulation and enhancement of the fishery. Today at the Pacific Biological Station and its sister scientific centers, the West Vancouver Laboratory, the Institute of Ocean Sciences at Sydney, and on research vessels at sea, the high standards he set continue to be adhered to.
You know what Newton said? He said that if I could see further than most, it's because I stood on the shoulders of giants. Now, in our smaller, more mundane way, this is what we are. We stand on each other's shoulders. We are a part of a chain.
Taylor was such a giant, and over the next 8 decades, he would be followed by a chain of other dedicated researchers at the station. Many would gain international acclaim for their work in the scientific world, and yet remain virtually unknown to the Canadian public at large. People like Edith and Cyril Berkeley. They came to Departure Bay in 1918 and worked for nearly 50 years as unpaid volunteers. gaining international renown for their research on seaworms or polychaetes. The only payment they received was the joy of scientific discovery, and for most scientists, that's enough.
The rewards of being a scientist, to a scientist, are great. First of all, there is a passion satisfied. Now, what can be more rewarding? Something which you are striving with all your being to obtain, suddenly you've obtained it.
In the 1920s, funds were at last made available to pay research staff, and the station expanded. Many new researchers were attracted to Nanaimo, and they made their mark. Like Dr. Dan Quayle, who, over the 40 years he worked at the station, published 125 papers on the biology and aquaculture of oysters, clams, and other shellfish. Now retired, he travels throughout the third world, helping developing countries establish their own shellfish culture industries. Dr. Bill Ricker became world famous when in 1954 he published his celebrated paper on stock and recruitment.
Stock and recruitment is a very simple idea. It simply says that the number of fish that are going to be recruited into the fishery is related to the number of parents that are spawning.
Ricker's paper revolutionized the field of fish population dynamics worldwide. Others, like Keyes Groot, gained widespread attention for their work on the study of a particular species, like salmon. Through a series of ingenious experiments, Dr. Groot and his associates gave the scientific world a glimpse into how salmon actually navigate their way from the streams of their birth out into the ocean and back again. He came to the fascinating conclusion that salmon employ a number of methods to navigate, including gravity, the Earth's magnetic field, odor, currents, and celestial navigation. In clear weather, they appear to get their bearings from the sun. In cloudy periods and at night, they keep their course by orienting themselves to the Earth's magnetic field. However, during their final journey upriver to spawn, they seem to be guided by the unique odor of their birth stream, often spawning in the very gravel beds where they themselves were hatched. Taylor's principle of applying research to the fishery was never lost sight of. A good example of this came in the 1950s, when the nation's vital Pacific salmon fishery was challenged by the expanding presence of the Japanese salmon drift net fleet. The International North Pacific Fisheries Commission was established to protect North American salmon stocks on the high seas. But there was a problem, because Asian and North American stocks became intermingled in the mid-Pacific. It was impossible to identify the Canadian salmon from the Asian.
The question was, is there any other way of proving that they are catching our salmon rather than going through the long and difficult and time-consuming and expensive way of tagging salmon?
Dr. Leo Margolis came up with a brilliant solution.
We discovered, indeed, that there were some parasites that the young salmon acquired while they were in fresh water, before they left their freshwater rearing areas to take up their marine residence. And that some of these parasites stayed with the salmon throughout their life. And because they stayed with the salmon throughout their life, once you went out to sea and caught fish at sea, if they carried particular parasites, then you can identify where they had come from.
This technique of using parasites as biological tags proved extremely successful and averted what could have been a major crisis in the international Pacific salmon fishery. With the expansion of the Pacific fishery, the station increased its investigations. Now scientists were no longer restricting the bulk of their investigations to the rivers, lakes, and coastal waters. They were moving out onto the high seas. The little flotilla of rowboats Taylor made available to visiting scientists in 1909 had been replaced. First the G.B. Reed, now the W.E. Ricker. They have plowed the Pacific from California to the Bering Sea and westward to Japan, investigating the whole ocean environment. Because it's clear Canada's Pacific coast fishery does not exist in isolation. It is inextricably tied to the planet's whole ecosystem. Now, instead of studying one species at a time, scientists study the whole community of fish stocks.
By a community, I mean the whole network of different species living together in a common area, whether it's in the Straits of Georgia or if it's in a lake, how they depend on different food items and how those food items depend on the plankton that's produced in the surface water.
Although these extensive oceanic studies may seem complex and remote, they're vitally important to the continued health of the BC fishing industry.
I think science is a big part of it. We need it. I think without it, we'd be in serious trouble.
So I feel my work covers a wide spectrum of what's going on in the fishing industry. From my research, which is very much the science part of it, but also in going to industry meetings and discussing with industry the science we're doing, how it affects them.
I think it's fair to say that we probably have the best managed fishery in the world, bar none.
Now, with the advent of fish farming, researchers at the station have set up programs to assist the new industry, particularly in the fields of fish health and vaccine development.
I'd say there's probably a virus at work in here. We'd better get them to do a virus assay for us.
Scientists have also been working on making domesticated fish stocks more marketable. In the West Vancouver laboratory, Dr. Ed Donaldson's team have come up with some remarkable breakthroughs in this field. Working in close cooperation with industry, they have been successful in manipulating the basic DNA of Chinook salmon so only females are hatched. These female Chinook are highly desirable in the marketplace because they grow considerably larger and, unlike males, all mature at the same time. As the station and its sister facilities look ahead into the 21st century, it's impossible to predict where the field of marine biology will go. But one thing is certain: George Taylor's principles of doing meticulous, well-documented science and sharing the fruits of that science with other researchers will still prevail. The other thing that's certain is that new breakthroughs in marine biology will only be attained by workers totally committed to their science, as committed as those who worked here in past years. Like Doctors Ricker, Westerheim, Butler, Quayle, and Cabata, still driven by the thrill of discovery.
It's something which is rare in your life, but which comes, and it comes like a high that no drug ever could give you. You have found the truth, or what you perceive to be the truth, and order.
And these veterans are not alone in their love of biology and their desire to discover. It's enthusiastically shared by younger researchers at the station, too.
need to know the answers, and that it doesn't stop at 5 o'clock, because it's a personal thing, and so you work on it all the time, and you're always thinking about it, and I like that. I really like that. I like the challenge of that kind of work.
George Taylor would be delighted.